Hi friends, welcome to #Meet. Good to see you after a long time. After the successful Java 8 series, I'm back with the core Java sessions. So in this session, we'll consider one of the most important topic, that is collection framework in Java. So do keep liking, subscribing, and commenting to my channel, that is #Meet. So let's move on further. So see, the collection framework hierarchy is shown in the picture. So the root hierarchy is the most important. The iterable interface is the root hierarchy. It is extended by collection root. Here, that extent is indicated by the solid black line, and implements is indicated by the dotted black line. So, collection basically it extends iterable interface, and it is in turn extended by set, queue, list, and map interface. So the set is it, it has a set is implemented by abstract set, which is extended by hash set and linked hash set. So linked hash set basically extends hash set, and hash set extends abstract set. So this is the uh, multi-level hierarchy it follows in this case. And similarly, we have tree set, which is extended by a navigable set. Navigable set it extends a sorted set, and sorted set is extended by set. Sorted set extends set. So I meant to say. Similarly, we have array list, vector. These are the subclasses of the abstract list. They extend the abstract list. Um, Also, we abstract list is implemented by the list interface, and the list is extended by collection interface. Followed by that, here we have queue. Queue is an interface that is extended by DQ interface, and followed by that we have abstraction sequence list, which is extended by linked list. So this was about set, list, and queue. Note here we do have map for that. So map is basically an interface. Its peculiarity stores the values in the key value form. Thus every keys must be unique. That's the condition over here. And there are also some other factors which I will show in the next slides. So only you need to consider that map interface is implemented by abstract map, and below that we have a hash map, linked hash map, and also we have sorted map, navigable map, which is implemented by tree map. So this is the overall view or the broad collection framework hierarchy diagram. You not necessarily just need to remember or just mug up this thing, but just you need to understand that what is extended by what and what is implemented by what. That's important. Let's move further. So as I told that collection is the root hierarchy interface or the main interface that extends the iterable interface. So this is a code snippet of the collection interface. As you can see, there is public interface, collection extends iterable E. Note here, E is the generic over here, and it can hold any kind of data type over here. So it's annotated by E, and it has some basic operations. So the size is empty, contains, add, remove, iterator. Note here that add and remove are optional. Also, we have iterator uh, method of interface iterator, and these are some basic operation. Followed by that, we have some bulk operation such as contains all, add all, remove all, retain all, clear. So these are again optional. When I say bulk operation, is that it operates on some multiple elements. That's the main literal meaning of bulk operations. So contains all, it will check whether that particular uh, collection contains that string or that needs to be compared, and it contains all, it will check all the elements in the collection, and all will add the all the elements to the respective collection. So remove all will remove and retain all will retain the elements of the collection. So just you need to consider in English literal meaning. Followed by that we have clear. We clear the list. Also there are some array operations. Object to array. So object to array means it literally converts a collection to the object array. Also we have the to array. You note that we have T as a generic and that T array, it contains a to array method that is called with a T array, which is the array. It can be of any generic data type and it's passed as a parameter. So basically this was about the interface of collection. So let's move further. Now consider set interface. Now we'll set in is an interface in collection framework that cannot contain duplicate elements. So that's its specialty. So it contains only unique elements. They can be represented by mathematical set abstraction used to represent set comprising unique elements like set of unique employee identity cards. So you so there there are situations in you need uniqueness. So over there specifically set interface should be used like the set of unique employee identity cards because identity cards are specific to specific employees. So also the set of cards from the card set, as there are 52 cards in the card set and each card has its unique value. So it's an again the best example of set. And majorly hash set, linked hash set and tree set are the implementations of set interface. Let's move further. Now consider the here we have the interface set that extends the collection. So as you can see there is a code over here. In that I have interface public interface set extends collection. So also there are some basic operation that are present in the as in the previous slide as a show size is empty contains add remove iterator. These the operations are there. Also the bulk operation that also contains all, add all, remove all, retain all, clear. So basically the code that is present in the collections, the same similar kind of code is present in the interface set. It just extends and it provides its some own method also for this, as you can see in the screen. And we have array operations such as object to array, and also as we were seeing in the previous slide, similar kind of that. So this is the sample code snippet of set extends collection. So let's move further. So list is an interface in collection framework that can contain duplicate elements as well as unique elements. That's especially with list. They can be represented by a list of user-defined objects like list of employee addresses. They can be any kind of addresses. There can be multiple addresses. A list of shopping carts. They might be unique or non-unique. They also can contain duplicate elements. Also the list of phone numbers. Some of the example of list. Also we have array list, linked list and vectors. There are major implementations of a list interface. Let's move further. So public interface list extends collection. So there are some methods such as get. In that we specify the index for which particular index we need to get from the list. Also we have similar to get we are set and that particular element where we need to set that element, and that particular element is included by e element. Also we have add e element, boolean add method, void add int index e element, e remove int index, boolean add all int index collection extensive options. These are methods that are optional. Followed by search, we have index of, last index of. So if you want to obtain the last index, that can be obtained by last index of, and you have to specify the object type over there. In iteration, we have also have list iterator and that list iterator, and in list iterator it contains a old method in which the index is passed as a parameter over there, and we have range view in which we extract the list sublist from the original list, and we specify the from and to. In from indicates the starting index and to indicates the ending index. Now let's move to the next part. The list iterator. The list iterator basically extends iterator, and it provides some list specific operations to the iterator. So it extends iterator. So it has next has previous, uh, previous, next index, previous index, remove, set, add. Over here has previous as a list iterator specific method, and also there is a next index and previous index methods. These are specific to a list index, and some of the common methods are like the has next, and previous that are from the original iterator methods, which we'll again see later. So basically, list iterator will add some additional, provide some additional method to the iterator to provide some list specific implementations. Let's move further. So after that, we have queue interface in Java. So queue, as per the English meaning, indicates sequence of elements on the basis of first in, first out. As per the data structure, any element added in the queue first will be removed after the completion of its task. Example, queue of people paying bill at the shopping mall. Besides, insertion and deletion queue also provides some additional operation like extraction and inspection operation. So any kind of queue you might consider, be it for paying some bills or some any kind of admission queue for admission fee, paying the admission fees of students. So these are the best example of queue and in the real-time scenarios in which queue is used. And as in the real-time scenario, the first person that is went first will go out first. So similar kind of concept is used in the queue interface. So let's move further. So as you can see, public interface queue extends collection, and it has some specific methods such as element. It returns the head of the queue, the element, throws an exception if the list is empty. So you need to consider that. Add new element to the last inserted element, returns true if it's successfully added. Otherwise, it throws an exception. Uh, So similar to add, we have offer. Adds element into the queue, returns true, successfully added, else it returns false. So advantage of picking offer is that if it doesn't throw an exception, it only returns false as there is a element is not successfully added. Also we have peak, it returns the head of the queue, throws exception if the list is empty. Also we have remove, it returns remove the head of the queue, and poll returns null if the queue is empty. So according to need, one should call the set method from the queue, and means be it an operation related to adding some element in the queue, removing some element from the queue. So taking some head of the not some I mean to say it's the head of the queue. So there is some specific methods are there that will serve the purpose. So this was about queue extends collection. Let's move further. So after that, we have map interface in Java. Map interface stores elements in the form of key value pairs. Key being no key. Key is the unique identifier for the particular value. Value can be of any valid data types like short, integer, float, boolean, etc. And the specialty of map is map cannot contain duplicate keys, and each key can store at most one value. So only one key is associated with one value, and vice versa. So that you need to consider. And besides that, we have hash map, linked hash map, and tree map as a major implementation of map interface. So let's move further. Here is the sample code snippet of map interface. So there are some basic operations, that is put, get. These everyone might be knowing, put and get. So some elements necessarily needs to be inserted. We need to make the use of put method, and if some elements need to be retrieved, we make the use of get method. So we have v put key k key v value. So put the elements are put on the basis of key value and get on the basis of key. So on the basis of key we fetch the values, and also on the basis of key we remove the value. So for that we need to know what is the key of that specific map element. Also we have some methods like contains key. So on object key we check whether that particular map collection contains that specific key, contains value, whether the specific value is contained in the map collection. So there are methods size. By default the size of map is 16, and there are some methods like is empty. There are some bulk operations also in it, like put on. So it will put all elements in that map. Clear collection views like set, key set, values, entry set. So basically key set returns the set of all the keys. If you want, there is key set method, as you can consider there's a bunch of keys and we want all of them, so we can retrieve um, uh, the use of key set method. Followed by that we have values and entry set. And set, as I said, set is used because as I said, set is a interface that contains only unique elements. So to specifically retrieve the unique values from it, use the set map entry key value entry set over there. So also there is a interface entry, which this method is a k get key, we get value, we set value, v value. So we'll set the value for that specific map element. Let's move further. So that was about interface map. So lastly we have iterator interface in Java. So iterator is an interface that enables us to traverse through the collections. It contains methods such as has next, previous, to check whether a collection has elements or not. So basically when we need to traverse through the entire collection, iterator is used. You can get iterator for collection by calling the iterator method. As for example, because I've shown mobile phones, taken a mobile phone list, and I instantiated by using array list. I've added some values to it, like Apple iPhone 11, Samsung M30s. And now note here that I use the iterator string get iterator over there, and the mobile phones.iterator over here. So I basically called the mobile phones.iterator. So on the list I called the iterator to in order to because I want to navigate through the list. So on the list I call the iterator method. So when on the list I call the iterator. So note here that mobile phones.iterator will it will call the iterator method on the list, and the elements can be get using the next method. And what does the has next just checks whether there are some other elements in the iterator using has next. So it returns true. It will return. It will go on returning true until there are some element that exist in the iterator. And so while get iterator or hard next, it will check the whether the elements exist in the iterator, and get iterator next will return the next element from the iterator as per the literal meaning goes, and it will print the output will be Apple iPhone 11 and Samsung M30s. Using iterator, we have navigated through the list. That's the importance of iterator. As I was told, there are some built-in methods over that. As in the previously we've seen the some additional method in the list iterator. So iterator also there's some built-in method like as next, remove. So remove is basically optional, but when iterator is there, has next and next needs to necessarily needs to use. So these are the built-in methods of iterator. So according to need, the some elements need to be removed. It might be removed using the remove method from the iterator. So while iterating, it will remove the specific element. So this video was all about to giving the overview of the collections framework in Java. So this is not the entire video covering all the concepts, but just to give the overview and brief idea about major concepts in collections framework. So more to come on collection related topics, collection framework related topics, and core Java topics. Do keep liking hashtag TechieMeet. Bye for now.